What's up, gamers? This is Henderson back with another Minecraft stream. Just kidding. This is me recording a video for all the people who have been gone and different things, whether for the senior trip or for PALS interviews. And if you missed the Phet discussion that we kind of went through with notes today, this is for you. So tune in. If you're interested, I posted a copy of this key in Classroom. This kind of goes through what we discussed in class on Tuesday, and then we did notes over today. And so it shows you how to draw that series circuit with 3 resistors, and then the measurements that you should have gotten when you went through the Phet simulation. So if you haven't done it, obviously you should do this Phet simulation first, and then it also talks you through parallel as well as the relationships. So I'm going to kind of go through this really quickly on the circuit construction kit just to make sure you can understand it. So when you're doing the voltage, obviously you need to touch your device across the different things you're measuring. So here I see a 3-volt reading. And if I do the same thing for my other light bulbs, I get a 3-volt reading, and then same thing for the last one. If I measure the voltage of my battery, I see that it's a 9-volt battery. And so one of the main things that you see here is that for a series circuit, the voltages add up to the total voltage of your battery. So your circuit as a whole is going to have the conservation of voltage. In other words, whatever I produce in my battery is going to be used up by my resistors. So that was the first big take-home message. The other things you notice is that on a current reading, you get a current that's pretty much the same no matter where you measure it. And so that tells us that current in a series circuit is constant. And that makes sense. If everything is having to flow along this one pathway, we turn on the current, you can see that they're having to flow equally throughout all parts of the circuit. And so it would make sense that the reading would be the same no matter where I measure. Whereas on the parallel pathway, it's possible to get different currents at different spots. There it says it's 2.7. On the lower branch, I can see that it's 1.8. And then on this lowest branch, it's 0.9. And if I go after this junction, I can see that this one also has 0.9. And then this one has 0.9. So you can see that although it's splitting at different junctions, it's going to end up having the same current across each resistor since these light bulbs are identical. We see each one's 10 ohms. So the current on a parallel circuit would be found by adding up the currents in the individual pathways, whereas the current for my series circuit, like we pointed out, is always the same. You can see that here on the Phet simulation. So that's 2 big important ideas, and these have to do with Kirchhoff's laws, which we did notes on today. The last one has to do with the resistance. When you calculate the resistance in the first circuit, you see that it would require a resistance of 30 ohms. That's based on the fact that I have 0.3 amps of current, and then I have a 9-volt battery. As a result of that, that would tell me that I need at least 30 ohms of resistance. And if each resistor is 10 ohms, the thought process was that that should have led you to believe that to get resistance, you need to add up 10 and 10 and 10 to get 30. So that tells me for a series circuit that the resistance is found by simply adding them up. If you have a bunch one after the other, you add up all of your resistances, you get a total. For a parallel circuit, we see that the situation is a little more complicated. For our overall amperage being 2.7 amps and my voltage of 9 volts, that would lead me to reason that I need 3.3 ohms of resistance. And the only way to get that would be to add up the inverse or the reciprocal of the 10 ohm resistor. And so I would do 1 over 10, 1 over 10, 1 over 10, and then I would do the inverse of that to get 10/3, which would give me my 3.3 that I'm interested in. So basically it's this complicated equation right here in the bottom. So with series, add them up, parallel, add up the reciprocals, and then take the inverse of that. And that would give you your kind of breakdown for each of the different circuits. So again, if you haven't had a chance to go through this simulation, I hope you'll take a chance to do so. And if you have questions, then hopefully the notes over Kirchhoff's laws will clarify anything you're still confused on.